Good morning, girls. Children, we are going to study some more criterion for the congruence of triangles, and then we'll start with the exercise 7.3, right? Coming to some more congruence rules. We have already studied these SAS, okay? Number two, we have done ASA, then we have done AAS, okay? Now you are familiar with SSS rule, and also you are familiar with RHS congruence. So today we are going to study these two, and we'll apply these two congruence conditions in the exercise questions. Now when we talk about the SSS rule, which means side congruence, okay? Now if I make two triangles ABC and triangle DEF, okay? Suppose AB is equal to DE, AC and DF are same, BC and EF are same sides. So when we have to prove the SSS rule or the criterion, we can write in triangles ABC and triangle DEF, number one, AB is equal to DE, number two, AC is equal to DF, and the third part is BC is equal to EF, right? So we can write that when the three sides of one triangle are equal to the corresponding sides of another triangle, corresponding three sides of another triangle, then the triangles are congruent by SSS criterion. I repeat, we can write the statement as if, or we can write when the three sides of one triangle are uh, equal to the corresponding three sides of another triangle, then the triangles are congruent by which rule? By SSS criterion. Okay, so now you know that when the three sides are equal of another triangle, like I've shown you here, when the three sides of one triangle are equal to three sides of another triangle, then we can apply the SSS rule. Now the next one which we are going to study today is the RHS congruence. You know how we make the RHS, that is how we prove the RHS criterion with two triangles which are right angle triangle ABC and DEF. As you can see here, this is a right angle. Now when we have to talk about RHS, it means right angle. Then there has to be hypotenuse and side, any one side. It can be a perpendicular or it can be a base, right? So in triangle ABC and triangle DEF, first point, if I take angle ABC is equal to angle DEF equals to what? 90 degree. Then it is given that this side, that is hypotenuse, is equal to AC is equal to DF. So the second point will be AC is equal to DF, which is hypotenuse. And the third side is, suppose I have BC equal to EF. Okay, now it can be this side also, it can be perpendicular also. But in this case, suppose I take BC is equal to EF. I will write here side. Now as you can see that the corresponding three parts are one right angle, one hypotenuse and one side, and therefore I can write, therefore the triangles are congruent by RHS criterion. And you know how we write a congruence? ABC is congruent to triangle DEF. Okay, so this is what the whole exercise 7.3 is based on. SSS and RHS. In between, maybe you have to use SAS, ASA or AS. That depends on the question. So I hope it is clear to you that when the three sides of one triangle are correspondingly equal to the three sides of another triangle, then the triangles are congruent by SSS criterion. And here you can write, when the right angle, hypotenuse and one side of one right angle triangle is correspondingly equal to one right angle, hypotenuse and the side of another triangle, then the triangles are congruent. Okay, now the statements I think are given in the book, you can learn it. If three sides of one triangle are equal to the corresponding three sides of another triangle, then the two triangles are congruent. I use the word corresponding means the side, when we were studying congruence, I told you that when we superimpose these figures, they should exactly cover each other. So I have to use the word corresponding equal side. That means if this is 3.5 and this is 3.5, so I have to write that these two sides are equal. Okay, so I hope you understood the meaning of the word corresponding. Then if in two right angle triangles the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of another triangle, then the triangles are congruent. So this is another theorem RHS which I have showed you how to prove. Now we come to question number 1 from the exercise 7.3. I hope children you have completed your previous work. If not, see that you complete as early as possible. Question number 1 says that there are two ABC and DBC are two isosceles triangles on the same base BC and vertices. Okay, so I'll draw this figure. This is A, B and C, right? Then DBC. There's a point here D which is at B, touching B and touching C, right? Now it is saying that both the triangles are isosceles. So triangle ABC, in triangle ABC, AB is equal to AC. Let me mark this, AB is equal to AC. Then in triangle, this point is D. Now in triangle, which one? DBC. DBC, this DB is equal to BC, right? DB is equal to DC. Okay, so this is what we have given. This is what is given in the question. Now they are saying that A and D are on the same side of BC and A is joined to D, yes, and it is produced to P. And where is P? P is lying on BC. Okay, it is intersecting, AD is extended to intersect BC at point P. So I have drawn the figure. We now have to prove there are four equal paths we have to prove. Equal paths, corresponding equal paths or congruent triangles. So the first one is triangle ABD is congruent to triangle ACD. This is number 1. Number 2, triangle ABP is corresponding equal to or congruent to ACP. Third point is AP bisects what? Angle A as well as angle D. And the fourth point is AP is a perpendicular bisector of BC. Okay, so starting with the first one, ABD and ACD proof. Now we can apply whatever congruent conditions are suitable here. We'll apply that. In triangle ABD, and ACD. Okay, now check. ABD, ACD. Now as you know that AB is equal to AC given because it is an isosceles triangle. Similarly, BD is equal to DC. This is also an isosceles triangle. Okay. Now we are talking about ABD and ACD. So let's start with the proof. First point will be AB is equal to AC. Reason is triangle ABC is isosceles. Okay. Number two, we will write BD is equal to CD. We will write triangle DBC is isosceles. Okay, I'm writing also and I am explaining also. Then the third point will be, as you can see that the third point will be AD will be equal to AD. It is a common side, so I will write AD is equal to AD common. Okay, now I have written all the 3 points. You can check. AB is equal to AC because triangle ABC is isosceles, BD is equal to CD, DBC is isosceles, and AD is equal to AD common. And as you can see that there are 3 sides, we will write which congruence. The triangles are congruent by the SSS congruence condition. Now, when the 2 triangles are congruent, we can write angle BAD, or we can write DAB. Okay, angle DAB is equal to angle CAD. Yes, we can write here CPCT, and therefore AD bisects angle A. This is the point which we have to prove in the third part, but because the 2 triangles are congruent over here, these 2 triangles are congruent, I can write that AD is the bisector of which angle? Angle A, because DAB will be equal to DAC, or CAD is equal to BAD. We can name it in 2 ways. Okay, now coming to the second part. We will take triangle ABP and triangle ACP. Okay, when you look at the 2 triangles ABP, ACP, right? First point. What is the first point? AB will be equal to AC. Again, ABP, ACP. Okay, this is given, and we know that why? Because triangle ABC is isosceles. Second point, we can write AP is equal to AP what? Common. Right? Now this is a common side. Now what is the third point which you will include over here? This. Can I write angle BAP is equal to angle CAP? Yes, I can write third point as angle. Actually, I had written DAB in the previous part when I was, see, it is DAB and CAD, but you know that P is a point which is means actually I had written DAB and DAC. Now I can write it as PAB and PAC, because you know that P is the point which is means AP is a line segment. So this whole line I can consider and write PAB is equal to PAC. Okay, so third point will be PAB is equal to PAC. Okay, and I will write here proved above. Okay, now which congruence condition you can check here? This is a side, this is a side, and this is the angle. Okay, the angle is between the two included sides. So therefore I'm going to write triangles are congruent by which side angle side rule. Okay, now side angle side rule I've written. Yes. Now uh, after taking the two triangles to be congruent, I can now write in this BP is equal to PC CPCT. Okay, BP is equal to PC. What? They are corresponding parts of the congruent triangles. Okay, which triangles? ABP and ACP. Now, coming to which part now? They're asking you to say that it is the bisector, right? So now let us consider. Now for the third condition, let us consider the triangles. This is a question which is little lengthy, children, because it has 4 parts. Now we'll consider these triangles BDP, triangles BDP and triangles CDP. Can you see any equal sides? Yes, we can write BD is equal to CD. BDC is isosceles triangle, right? First point. Number two, we can write DP is equal to DP. It is a common side. Yes, it's a common side. And BP is equal to PC. Third point, proved above. Yes, proved above. Now, again we've got the 3 corresponding sides, 3 sides. So we will apply here which rule? Congruence rule, and that is the SSS rule. Okay. Now, why we have taken these 2 triangles taken to be congruent? Because when we take these 2 triangles to be congruent, we can now write BDP, this one. Okay. Angle BDP will be equal to angle what? CDP. Yes. So I have written here BDP is equal to angle CDP, and this will be CPCT. And therefore I can also write that AP bisects angle D. Here I have written AD bisects angle A, but here I am writing AD bisecting angle A. Here I am writing AP is bisecting angle D, which has the same meaning which is asked here. Okay, AP. So here also instead of AD I can write it as AP. Okay, because you know AP is a line segment which is bisecting both the angles A and now angle D also by CPCT. Now, what is the fourth point? The fourth point is AP is the perpendicular bisector of BC. Now, as you can see that BC is a line. Okay, BC is a line. BC is a line. So I can write BC is a line. Angle, this one, BPD, angle BPD plus angle CPD. Okay, check these 2 angles. All the 3 conditions we have proved. And for the last point, now you know that this forms a line and this is a linear pair. Okay, so for the linear pair I can write BPD plus CPD is equal to what? 180 degree, forming a linear pair. All the 4 parts are complete, children. And then BPD is equal to CPD. Why? Because we can write that when the 2 triangles are congruent, these 2 parts will be equal. Okay, so BPD is equal to CPD. We can write CPCT. Instead of BPD, plus I can write BPD equals to 180 degree, twice BPD equals to 180. So therefore angle BPD equals to 90 degree. So this is what we had to prove in the last point, that AP, so I can write AP is the perpendicular bisector of what? BC. How bisector? Because BP is equal to PC. And how perpendicular? Because angle BPD is equal to 90 degree. So this completes your question number 1. Today you complete this question and the 2 congruence conditions, and then I'll continue tomorrow with these exercise questions. Thank you. Have a nice day.